This is a pretty difficult question that combines partial fractions along with binomial expansion, year 2 binomial expansion that is, and I'll go through how you know it's year 2 and not year 1. So it tells you that this whole expression here can be expressed in this format, and it's asking you to find the value of b and c and also show that a is equal to 0. So let's split this up. In order to compare this format here to the actual function, what we need to do is make the denominators of each fraction the same. So if we think about it, this term here, in order for it to have this denominator, we need to not only multiply by 5x plus 2, but also 1 minus 2x. Whatever you do to the denominator, you also apply to the numerator of the fraction. So you're doing a multiplication of 5x plus 2 and 1 minus 2x to the numerator, just so you can get a denominator from here to all of this. I'm going to write a massive denominator here of what we're trying to get to, 5x plus 2 all squared multiplied by 1 minus 2x. Let's now think about the second term. What do we multiply to the denominator of the second term to make it match the denominator of our answer? We need to multiply 1 minus 2x. So once again, we do that both to top and bottom of the fraction. So you add onto that. Sorry, that looks like a plus 2x. That's 1 minus 2x, by the way. I'll write that out again. So we add onto that b lots of 1 minus 2x. Applying that same concept to the c term, it already has a 1 minus 2x in the denominator, so we have to multiply 5x plus 2 all squared onto both numerator and denominator in order for us to write in this fractional format. So let's do that. C lots of 5x plus 2 all squared. Now that we have this fraction, we want to compare it to the answer that we want to relate it to. So 50x squared plus 38x plus 9 over this denominator that we made everything equal to. 5x plus 2 squared multiplied by 1 minus 2x. What we can then do is, because we know two fractions on each side, for them to be equal, the numerators must match. We can make the numerators match each other. We can say that the numerator on the left-hand side, which I'm just going to very quickly write out, plus b lots of 1 minus 2x, plus c lots of 5x plus 2 all squared, equals the numerator on the right-hand side. 50x squared plus 38x plus 4. 9, sorry. My bad. I just looked at the question and realized it's a 9. Okay, so where do we go from here? Sorry, by the way, my handwriting's awful today. I'm trying to write neater from now. We now substitute values of x into this expression in order to eliminate terms. So, for example, if you put x equals minus 2 over 5, why I chose that is, if we make this bracket equal to 0, we subtract 2 and divide both sides by 5, we get x equals minus 2 over 5, would make that bracket equal 0. Not only will it make this bracket equal 0, but also it will make this bracket equal 0, because 5 times minus 2 over 5 plus 2 is 0. However, this b term, well, 2 multiplied by, okay, let's write this out. B lots of 1 minus 2 times this expression here. 2 times minus 2 over 5 is minus 4 over 5. 2 minuses make a plus. 1 plus 4 over 5, well, 1 is like 5 over 5. 5 over 5 plus 4 over 5 is 9 over 5. So we can write this as 9 over 5b. And then to get what it's equal to, we're going to put x equals minus 2 over 5 into the right side of that equation. I'm going to put that in my calculator very quickly. Just bear with me one moment. So 50 lots of minus 2 over 5 all squared plus 38 lots of minus 2 over 5 and then plus 9. That's equal to 9 over 5. In which case, it pretty much makes sense that b is just equal to 1. Great, let's now substitute another value of x to eliminate a term. In this case, it makes sense to put x equals a half, because if we make this bracket equal 0, 1 minus 2x equals 0, we can add 2x to both sides, we get 1 equals 2x, and divide both sides by 2 to get that x equals a half. So when you put x equals a half into this bracket, it makes it equal 0. It also makes the b term equal 0. However, it doesn't make the c term equal 0. So let's replace x with a half and see what happens to this term. So we have 5 times a half plus 2 is equal to 9 over 2. 9 over 2 all squared is, so let's write this out. C lots of 9 over 2 all squared. 9 squared is 81. 2 squared is 4. So 81 over 4c is equal to what you get when you put x equals a half into the whole expression here. So let's do that. I'm just going to make this a little bit larger. Okay, so we have 50 lots of, sorry, I just remembered the x value, 0.5 all squared plus 38 lots of 0.5 plus 9. And that's equal to 81 over 2. Now from there, it makes sense that c is just equal to 2, because if you make it equal to 2, then this 2 cancels out with this 4, leaving you with 81 over 2, which is what we want on the right hand side. Now that we've got B and C are both given, it also wants us to show that A is equal to 0. How do we do that? Well, I think the easiest way is to honestly just substitute a random value of x into this expression, both sides of the expression, by the way. That isn't minus 2 over 5.5, because we've already done those. In this case, let's do x equals 0. So when you put x equals 0, the A term becomes, well, 0 plus 2 is 2. So we have A lots of 2 lots of 1 minus 0 is 1. And then plus B lots of 1 minus 2x is 1 minus 0. And then plus C lots of 0 plus 2 is 2, all squared is 4. So that becomes 2A plus B plus 4C. 2A plus B plus 4C equals what you get when you put x equals 0 into this whole expression here, which is 9. Because we already have b is equal to 1 and c is equal to 2, let's put that into this expression. So we have 2a plus 1 plus 8, which is plus 9, is equal to 9. And I'm pretty sure you guys can see where to go from here. 2a equals 0, in which case a is equal to 0. And that proves that a is equal to 0. Great, we've done that whole binomial expansion. A bit of a long process, but hopefully it made sense to you guys. Oh no, it seems like I can't raise all of that. Instead, let's just move on to this side of the whiteboard then. So we know that a equals 0, we know that b is equal to 1, and c is equal to 2. Let's now use that to find powers of x and multiply to give this format. Well, first of all, in order to expand this, we can't really do that yet, but since we put into this format, we can do it now using the binomial expansion formula. So first of all, this first term is 0, we can ignore it. This term here, I'm going to write out as 5x plus 2 all to the power of minus 2. And this term right here, we can write it out as 2 lots of 1 minus 2x all to the power of minus 1. Before you can expand it out, because it's a negative power, we have to use the formula that 1 plus a all to the power of n is 1 plus na plus n lots of n minus 1 over 2 factorial a squared. This is given to you in an exam, by the way. I'm never going to bother going on to the next terms because it only wants us to expand it up to x squared. And you want to expand both of them up to x squared and then collect like terms. This first expression here, we can't yet expand it because there's not a 1 for your first term. So we need to somehow make it a 1. We can do that by factoring out 5 from the inside of the bracket, in which case we have x plus 2 over 5, and then all to the power of minus 2. We can now apply the power of minus 2 to the 5 and this inner bracket. So it becomes 5 to the power of minus 2 multiplied by x plus 2 over 5 all to the power of minus 2. 5 to the minus 2 is the same as 1 over 5 to the power positive 2, which is 1 over 25. So we have 1 over 25, and then, oh, sorry, I just realized one thing. I wrote x here. I was supposed to write 1 plus 2 over 5x. Same here, 1 plus 2 over 5x. Sorry about that. Okay, that looks quite messy. Try to rewrite it. 1 plus 2 over 5x. A little bit better. Okay, now we can expand this out. So we have 1 plus na, so 1 plus n, which is the power of minus 2, multiplied by a, which is this whole term here, 2 over 5x. And then we have plus n, which is again minus 2, multiplied by n minus 1, which is minus 3, all divided by 2 factorial. Factorial just means you're multiplying by all the numbers, starting from that number back down to 1. For example, 2 factorial is 2 times 1, which is 2. A again is 2 over 5x, and this time all squared. And then close the big brackets that we started. Now, how I'd recommend you put this in a calculator? Well, first of all, minus 2 times 2 over 5 is minus 4 over 5. So that's just pretty much minus 4 over 5x. Oops, sorry. And then this term here, well, the 2 cancels out with this 2, leaving you with 2 over 5 all squared is 4 over 25. And then minus 3 times 4 over 25 is minus 12 over 25, and then x squared. From there, you can just multiply out 1 over 25. So you have 1 over 25 minus, it's quite a lot of working, isn't it? 4 over 125x minus 12 over 625x squared. Perfect. We've expanded this out. Now you want to expand this out using that same method. We don't need to do that extra step where we factor out something from in the bracket because there's already a 1 in the beginning of the bracket. So let's expand that out. So I'm just going to do this in a different color because it's getting a little bit messy. So what we're expanding out now is 2 lots of 1 minus 2x all to the power of minus 1. Let's leave the 2 outside the bracket for now. Actually, we'll join it onto this later. Let's expand this somewhere here. So again, using that same formula, in this case, a is going to be equal to minus 2x and n is going to be the power of minus 1. So we have 2 lots of 1 plus na. Na in this case is going to be minus 1 multiplied by minus 2x, and then plus n, which is minus 1, lots of n minus 1, all divided by 2 factorial multiplied by a squared, minus 2x all squared. Okay, so minus 1 times minus 2x is positive 2x. Minus 1 times minus 2 is 2 over 2 factorial is 1. So we have 1, and then minus 2 all squared is 4, so that becomes plus 4x squared. And then now we can expand out the brackets by multiplying everything in the bracket by 2. So it becomes 2 plus 4x plus 8x squared. So let's write that out here. 2 plus 4x plus 8x squared. Almost at the end now. Now we collect like terms. 1 over 25 plus 2 over 25, that's just 51 over 25. Minus 4 over 125x plus 4x. Okay, let's do minus 4 over 125 plus 4 on our calculator, and we get 496 over 125. That's 4 plus 496 over 125x. And then let's do this final bit on our calculator too. Minus 12 over 625 plus 8 is equal to 4988 over 625 x squared. And you can write plus dot 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 because there's a lot more terms that we're not taking into account. But that's it for this question. Last part of the, B part 2, you want to find where it's valid. You want to take the expression of both when it's in the form of 1 plus a to the power of n. You want to take the modulus of the a term, so in this case modulus of 2 over 5x, and make it less than 1. From there you want to solve for x, so you want to start by multiplying both sides by 5 to get modulus of 2x is less than 5. Modulus of x is less than 5 over 2. You then apply that same process to the other variable that you added. In this case, the modulus of minus 2x, you set that as being less than 1. Modulus of minus 2 is positive 2. So you can write this out. Modulus of 2x is less than 1. Now you divide both sides by 2, so modulus of x is less than a half. From there, you choose the one that's a stricter inequality, because that's the one that would be applicable to both. In this case, this is the stricter one. So that's your final answer. Pretty difficult question here, but hopefully it all made sense to you guys. A lot of writing. I'll zoom out so you can see all the writing. But yeah, thanks for watching the video, guys. Have a nice rest of your day. Thanks for watching. I hope this video helped. If you have any tutoring inquiries, be sure to visit my website, www.excellineducation.co.uk. It's on the first link in the description too.